Okay, we're going to do some questions involving proving tangency to circles. So we've got an example 1. We're going to show that y equals minus 3x minus 10 as a tangent to the circle with equation x squared plus y squared minus 8x plus 4y minus 20 is equal to 0. And the question then asks us to find the point of contact as well. Okay, so we sub our y equals minus 3x minus 10 into the equation, so it'll be x squared plus minus 3x minus 10 all squared minus ax plus 4 lots of minus 3x minus 10, close the brackets, minus 20 is equal to 0. That'll give me x squared minus 3x all squared is 9x squared. I've then got minus 3x times minus 10, which is plus 30x, and then another minus 3x times minus 10, which is 30x again. And then minus 10 all squared is plus 100, minus 8x, minus 12x, minus 40, minus 20 is equal to 0. I then get 10x squared, that's 60x, take away 20x is 40x. 100 take away 40 take away 20 is plus 40 is equal to 0. Now I could use either discriminant and get a value of 0 to prove tangency, or alternatively factorise the equal roots. So I'm going to go down that line. First I'll factorise and take out a highest common factor, so that would be 10 bracket x squared plus 4x plus 4, which is 10 bracket x plus 2 all squared is equal to 0. So equal roots x equals minus 2, therefore tangency exists. Okay, to find the point of contact then, look at the x coordinate, which is minus 2. I then sub x equals minus 2 into an equation for y to get the y coordinate. So I've got y equals minus 3x minus 10, so let's sub that in. Y equals minus 3 bracket minus 2 minus 10, and that's 6 minus 10, which is minus 4. So my point of contact then is minus 2 minus 4. Okay, let's try another question that's going to be interwoven with some differentiation work. Okay, so the question is asking us this time to find the equation of the tangent to the curve y equals 2x cubed minus 4x squared minus 7x plus 12, where x is equal to 2. Okay, so my first move is to differentiate, and that will give me 6x squared minus 8x minus 7. Okay, I'm then differentiating to find gradient, but it's gradient at x equals 2, so that's 6 lots of 2 squared minus 8 lots of 2 minus 7. 2 squared is 4 times 6 is 24 minus 16 minus 7, and that will give me a value of 1 for the gradient. I'm now going to find the y coordinate by subbing x back into y, so that's 2 lots of 2 cubed minus 4 lots of 2 squared minus 7 lots of 2 plus 12. 2 cubed is 8 times 2 is 16, 2 squared is 4 times 4 is 16, minus 14 plus 12, and that will give me minus 2. So my point of contact then is 2 minus 2, and the gradient is equal to 1. Y minus b equals m bracket x minus a. That's y minus minus 2 is equal to 1 bracket x minus 2. Y plus 2 is equal to x minus 2, and y will be equal to x minus 4. Okay, so that's part A. Part B brings in the circle element to the question. So the part B then says, show that this tangent is also a tangent to the circle x squared plus y squared minus 6x plus 2y plus 10 is equal to 0. So let's sub in y equals x minus 4. So x squared plus x minus 4 all squared minus 6x plus 2 bracket x minus 4 plus 10 is equal to 0. So it's x squared plus x squared minus 8x plus 16 minus 6x plus 2x minus 8 plus 10 is equal to 0. And that will be 2x squared, that's minus 8x minus 14x minus 12x. 16 minus 8 is 8 plus 10 is 18, and that's equal to 0. Okay, let's take out a common factor. 2 bracket x squared minus 6x plus 9, close the bracket, is equal to 0. Two numbers multiply give 9, add together give minus 6, minus 3, minus 3, so that's 2 bracket x minus 3 all squared equals 0. So, equal roots at x equals 3, therefore tangency exists. And to find the point of contact, I'm going to sub x equals 3 into my equation for y. So that's going to be y equals x minus 4, and that's y equals 3 minus 4, and y is equal to minus 1. So the point of contact then is 3 minus 1. Okay, next example. A circle has equation x plus 3 all squared plus y minus 6 all squared equals 61. Find the equation of the tangent to this circle at the point A33. Okay, and then there's a part B to the question as well, which we'll come on to. Okay, so first of all, let's establish the circle centre, which would be minus 3, 6. I can now find mrad, so the gradient of the radius then will be 3 minus 6 over 3 minus 3. That's minus 3 over 6 and minus 1 over 2. M tan mrad equals minus 1. So m tan flip and invert then will be positive 2. Okay, so we've got the point that lies on the tangent, and we've got the gradient of the tangent, and y minus b equals m bracket x minus a. Y minus 3 is equal to 2 bracket x minus 3. Y minus 3 is equal to 2x minus 6, and y will be equal to 2x minus 3. Part B then says, show that this tangent is also a tangent to the circle with equation x squared plus y squared plus 6x minus 7y minus 10 is equal to 0, and find the point of contact. So it's x squared plus 2x minus 3 all squared plus 6x minus 7 bracket 2x minus 3 close bracket minus 10 is equal to 0. Okay, so that will be x squared plus 2x all squared is 4x squared. 2x times minus 3 is minus 6x, and then another minus 6x minus 3 all squared is plus 9, plus 6x minus 14x plus 21 minus 10 is equal to 0, and let's tidy it up, so it'll be 5x squared minus 6x minus 12x minus 6x minus 20x, 9, 30, take away 10 is 20, that's equal to 0. Take out the highest common factor, x squared minus 4x plus 4 is equal to 0. Two numbers multiply give 4, add together give minus 4 is minus 2 and minus 2, that's 5. Bracket x minus 2 all squared is equal to 0. Okay, so equal roots at x equals 2, therefore tangency exists. Okay, to find the point of contact, I'm then going to sub the x equals 2 into y. Okay, so it's y equals 2x minus 3 y equals 2 lots of 2 minus 3, that's 4 minus 3, and that's equal to 1, so the point of contact then is to 1.